All right, calculus, we're going to start chapter 6 with this. And what we're going to do is talk about what is the antiderivative. And we're just starting right now, so hopefully we'll take this slow enough that this will make perfect sense. It sounds exactly like what it should. The antiderivative is the undoing the derivative. So just think about it for a second, and we're going to explain this in words on how to find the derivative of something. And let's just talk about polynomials, so like that x to the n power. Now let's say there's an a in front just for the sake of having some constant. Well, the derivative with respect to x of this function would be bringing the n in front, and remember you multiply by that constant, or coefficient I should say, and then we subtract 1 from that exponent, which I just had. Maybe you can use this in words, okay? So, if you wanted to, you can pause the video and you can write in words that you multiply the exponent of each term by the coefficient and then decrease the exponent of each term by 1. So when we're doing the antiderivative, we need to undo. And as we undo, we need to go in a backwards form. So notice in words here, the first step is to increase the exponent of each term by 1 and then divide the coefficient. Notice that's divide now instead of multiply. Now I'm going to introduce this notation to you as well. It's a Greek symbol. You don't need to worry about that, and there's a reason why they use that symbol, but we're not quite ready for that explanation. So you'll notice a few things though. I'm going to write that notation though. Let me just use a few different variables. Let's do like b x to the m power. And what you'll notice is we also put this dx here to say it's a differentiable function, because in order to be a differentiable, you need to, or in order to do the antiderivative, it needs to be differentiable. So the first step, because if you notice the first thing I did up here is I multiplied the n in front, the first step would be to add 1 to the exponent and then take that new exponent and divide, take the coefficient, divide by m plus 1, divide by the new exponent. And I do want to take a step further and explain that the derivative of this needs to go back to equal that. So we can verify that that's true by, if I were to ask you to find the derivative of b over m plus 1, x to the m plus 1 power, the first thing that you should do is bring this exponent in front. So b times m plus 1 over that other m plus 1, x to the m plus 1 minus 1, well, plus 1 minus 1 will cancel, so you're just left with m. Things cancel, and you're left with b x to the m power, which is exactly what I said here. So as I flip back, so in words, I talk about it this way, where you increase the exponent by 1 and divide the coefficient of each term by that new exponent. So go ahead and pause the video, reread through some of this. And what we're getting at is this antiderivative will undo derivatives. The issue, though, is that you might have multiple problems whose derivative is the same. What am I talking about? Let me flip back and scroll down a little bit. You might have a problem where I ask you to find the derivative of, I don't know, x squared plus 2 and x squared plus 3. Well, if you take the derivative of each of those, they'll each be 2x. So there's definitely some sort of issue, but we can fix it by if we ask you to do the antiderivative of some derivative, they'll undo each other. But then what we need to do is write this plus c at the end to let the reader know that there are multiple problems that could give you that derivative. So as I move on to the next problem, let me just put this in all caps. I actually have seen students write this out, plus c, all over their quiz or test, whatever it is, to make sure that they don't forget about writing a plus c. Because when you're doing this antiderivative, the whole premise is to work through it and find a general equation whose derivative equals 3x squared plus 2x plus 3. So as you see me work through the problem, I'm going to do this slowly first, and then you should get the habit and you should be able to work through this pretty well. Is you add 1 to that exponent, and then you take the coefficient, you divide by that new exponent, which those 3's will cancel. So add 1 to this exponent, you divide by that new exponent. So this 2 is right here, and then divide by this 2. Now there's no x here, but if it helps, you can think of it as x to the 0 power. X to the 0 power is still 1, so add 1 to 0 and you get x to the first. But then don't forget about plus c. And let me state this slightly different. Is what's the derivative of any constant? 0. Well, we're not going to write down 0 up here, so that's another reason why you need to have that plus c there. So this would be the best answer. And we'll talk about it, what to do if we have, when we don't want to have plus c here. The next problem, if you notice, we're dividing by a monomial. So as a reminder, you can divide each piece by x. So this is really the same thing as the antiderivative of x squared plus 2 minus 4x to the negative first power. Although you want to be careful when you look at that, and the dx is there for a reason. So as you watch me do this, I'm going to add 1 to my exponent and divide by my new exponent. I've also heard some teachers say multiply by the reciprocal of that new exponent, which is totally fine. Now here, I'm going to do this wrong for a second, because if I were to add 1 to that exponent and divide by that new exponent, well, we can't divide by 0, so that's wrong. Well, think about it for a second. At one point, we had a problem that was 4 over x, and think about what problem when we took the derivative gave us 1 over x. And that answer would be the natural log of x. And then don't forget about plus c. So this is your final answer for that one. So as we move forward, you just might want to remind yourself that the derivative of natural log of x is equal to 1 over x, or x to the negative 1 power. If you've forgotten that over the course of the class, then you might want to remember that. I can even go back to the answer key where I don't think he even writes it out. He just kind of assumes his class remembers it. So here's your answer key on that one, which matches my answer, so we're good. As I move forward, okay, we don't really have a product rule for the antiderivative. Okay, so let me warn you, there's no product rule. And there's a way around it, but that's a Calc 2 scenario. So what you want to do is rewrite this by foiling this out. 2x squared, negative 3x plus 4x would be plus 1x, and 2 times 3 would be negative 6. And this dx right now is just a formality. I'll explain that in a little bit, why we need that. So then the antiderivative, add 1 to your exponent, divide by your new exponent. Add 1 to your exponent, or multiply by the reciprocal. And there we go. But notice that rewriting the problem is very, very helpful for you. I think it is, at least. Like this one, it's helpful to rewrite this as 2x to the -1/2 power. So then you can actually see that you're adding 1 to your exponent. Well, -1/2 plus 1 is +1/2. Now this 2 is still here. And this is where I think it's useful, instead of thinking of dividing by 1/2, is to multiply by the reciprocal. And don't forget about your plus c. So this answer is 4x to the 1/2, or maybe rewrite it as the square root of x. Just be ready to simplify in different ways. So as promised, I'll show you the answer key, and you can see, you know, this person talks about dividing by that new fraction, but ends up multiplying by the reciprocal anyway. So certainly useful to some extent. Okay. Let me give you the last couple rules before ending the first part of this video, and that is with trig functions. Because we need to know the derivative of sine is cosine, so it should make sense if we do the antiderivative. That means we work backwards. Now this does confuse students because we're used to the derivative of sine being positive cosine, but when we look at the antiderivative of sine, it's actually negative cosine. And don't forget about plus c. I'll write that off to the side. But the reason for that is because we're working backwards. And what you can think about is, if I'm working backwards, then I need to divide by -1 over here. So the antiderivative of cosine is actually positive sine. And don't forget about plus c. So then looking at this problem then, you know, it's going to take some practice, because so you're used to at this point that the derivative of sine is cosine. But you got to think backwards. Everything's backwards. So this is -2 cosine of x. The antiderivative of cosine is positive sine plus sine of x. And don't forget about plus c. Always need a plus c here. And we can combine together the polynomial functions with the trig functions. So 1/3 t cubed. Notice that as you get more practice, this will become more obvious. And you can always check your work, because the derivative of this needs to equal this. So what's the derivative that gives you negative sine? That would be a positive cosine. So it's the derivative of cosine is negative sine. And you can double check my math. You can take the derivative of that, make sure it's equal. Same thing with this. I'm just doing the math in my head. Add 1 to your exponent, divide by your new exponent. 4 divided by 2 is 2. And I'm thinking about how the derivative of sine gives me cosine. So if it's -3 sine, the derivative of that is -3 cosine. And then plus c. And then over here, again, I'm just thinking about this in my head, that this is x to the 1/2. That as I add 1 to 1/2, I get 3/2. Instead of dividing by that, I'm going to multiply by the reciprocal. And I'm thinking about how the derivative of cosine gives me negative sine, so this needs to be negative cosine. I think this is a good place to stop, because we're going to get into a little bit more interesting stuff on the next example. So if anybody wants to see slightly different work, but the same answers, feel free to pause the video before I end it here.